The extended mission status of the Mars Reconnaissance Orbiter and the high-res camera has greatly increased scientists' understanding of numerous active processes occurring on Mars. By taking carefully planned repeat images of surface, scientists now have an important record of how the surface evolves for a maximum of 5 years on Mars. The image here shows the central peak in Porter crater. Although there are no repeat images here, scientists can infer several active geological processes based on morphologic evidence and lessons learned from past well-monitored sites. We can see here that there are shallow gullies located on the south and east-facing slopes of the central peak. These features might have been carved by volatiles such as carbon dioxide frost sometime in recent geologic past. Meanwhile, on the northern slopes are several smaller slope features that have a morphology hinting at recurring slope lineae. Alternatively, these features could be the remnants of past active gullies. Several more high-res images would be needed to characterize their behavior and confirm their status as recurring slope lineae. Southward on the slopes below the peak is a large dune field. Dunes here show sharp crests with prominent ripples, both signs of actively migrating dunes. Also, we can see dust devil tracks crossing the nearby dusty surfaces and clear evidence for ongoing modification by swirling winds that persistently remove surface dust. This strangely shaped rock displays a pointed peak and pitted nodular texture. On Earth, similar nodule textures can form through chemical weathering, mineral precipitation, or even volcanic processes. While the pyramid shape of the rock is often seen in wind-eroded rocks on Mars, it's the spherules on the rock that have scientists intrigued. Scientists think that in some rocks seen on Mars, these spherules form when groundwater passes through pores in sedimentary rocks. But they are not sure if all of them formed this way. Perseverance rover's science team is currently analyzing more rocks to search for answers to this Martian geological mystery and other burning red planet questions. For now, the rock remains a compelling snapshot of Martian history. Features like this help scientists piece together the red planet's environmental history, showing how wind, water, and internal processes may have sculpted the landscape over billions of years. Curiosity rover captured this 360-degree view after arriving at a region crisscrossed by hardened low ridges called boxwork patterns. When viewed from space, the boxwork patterns look a bit like spider webs. They have fascinated scientists since before Curiosity's 2012 landing on the red planet and are believed to have formed from groundwater trickling through rock cracks billions of years ago. Minerals left behind by the water hardened like cement within the rock, then after eons of sandblasting by wind, the rock was carved away, revealing networks of resistant ridges within. Curiosity's tracks can be seen in the middle of the image along with a large butte to the right. Far in the distance at the top center of the image is the rim of Gale crater. This image shows the southwestern floor of a 50-kilometer diameter unnamed crater about 100 kilometers northeast of Hellas Basin. The crater's rim is bridged on both the north and south by a valley system that previously flowed across the crater floor, leaving behind an interesting array of channel patterns and deposits as it transported water and sediments into and out of the crater. We can also see a portion of the channel system along the southwestern crater floor near where the valley breaches the southern rim. The darker toned surface has a pattern similar to the texture of a basketball and blankets the region both in the channel belt and in the basin below the cliffs. Superposed on this patterned surface are clusters of larger circular mounds that may be related to the thawing and freezing of ice-rich sediment, which is unusual at this relatively low latitude. Extensional cracks and clusters of pits makes this topography more complicated. The southern part of this image also reveals a prominent irregular scarp with light-toned layer deposits exposed along the margin beneath this textured surface. The light-toned layers look like an ancient mosaic in some areas as they are irregularly fractured and brachiated. Individual blocks and large boulders of this material are visible at full resolution near the scarp, just about to fall and already lying on the debris slopes below the scarp. Some are brighter than the others as they may be dust-free, indicating that they have detached from the cliff more recently.